I'm Anil Kumar. Welcome to my series on sets. Here is a very good application question based on De Morgan's law. You are given a universal set S which is equal to x such that x is between 15 and 30. Set A is defined as all elements x such that x is a prime number, and B is set of elements which are perfect squares. You need to find complement of A intersection complement of B, and also find number of elements in complement of A intersection complement B. So you can pause the video, answer the question, and then look into my suggestions. Now, we have many ways to do it. Let me also share with you a Venn diagram which can help us visualize the solution, right? So, and we'll also use De Morgan's law, a part of it, right? So it is De Morgan's law has two parts. One relates to what we're trying to find, intersection of complements of two sets, right? Now in this case, we are given a universal set which is right here for us. So this is the universal set S, and in that we have two sets, A and B. Set A is a set of prime numbers. That means they will have only two factors, one and the number itself. And set B is a set of perfect squares. So perfect squares cannot be prime numbers, right? So these are disjoint sets. So we can say, well, this is our set A, and then we have set B. Since we are talking about numbers which are between 15 and 30, it's a good idea to list all the numbers, right? So this is our set A and this is our set B. So the perfect squares between 15 to 30 will be 4 square is 16, right? 5 square is 25. So we have two elements in set B. As far as set A is concerned, we are looking for prime numbers between 15 to 30. So we get first number as 17, then we have 19, right? And then we have 23, and then we have 29, correct? So these are all the prime numbers between 15 and 30. So all other numbers are outside these numbers within our universal set. So let's make a note of those. So above 15, so we can write 16, but 16 is here, 17 is there. So we're left with 18, 19 is there. Then we can write 20, 21, okay. Then we can write 22, we will write here 22. 23 is there, we can write 24, 25 is there, 26, and then we have 27, and we have 28, right? So let me write 28 here. So how many numbers do we expect in all? We expect 15 minus 30 minus 15 minus 1, 14 numbers. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have considered all the numbers, right? Now look into what is required. We need to find complement of A intersection complement of B. While using De Morgan's law, you could also write this as A union B complement, right? So both are the same things. Okay, let's try to understand first how these things are same with the help of the Venn diagram. Now when I say complement of set A, right? This is set A. Complement means not in set A. So everything outside, right? So that's what we mean, correct? So everything outside will include everything, right? So even these points. So that is what we mean when we say complement of A, right? So we have done first part, complement of A. Now let's use another ink for complement of B. So complement of B, let's use this color. Okay. So that is outside B, right? So outside B means, let's shade it. So that is outside B, not included inside B. Do you see that part? So that is what it is. So wherever we have both the lines, that becomes its intersection, right? So the intersection is all the elements which are in both complement of A and complement of B, correct? You will notice from the given diagram that it is all the set of elements which are outside these. Do you see that? Inside we have only lines from complement of one of the sets, not from both. So outside this, that is the meaning of A union B complement. Does it make sense to you? So we could write this as all these numbers which are outside, and so these numbers are 18, 20, 21, 22, 24, 26, 27, and 28. Does it make sense? So that is how you get this. Perfect. So you could get it by making the Venn diagram or otherwise. And the number of these elements, which is complement intersection, or both complements intersection, is, count them, 1, 2, 3, 4, 5, 6, 7, 8. So we get 8 as our answer. Perfect. So that is how you're going to answer this particular question. The other way was, you could have written that number of elements in our sample are 14, right? Number of elements in A are 1, 2, 3, 4. Number of elements in B are 1 and 2. Correct? So we are looking for everything, and we know intersection of A and B is null set, right? So we know that the number of elements in A intersection B, because they're disjoint, right? It is a null set. So we can find what is A union B, right? Which is, and its complement. You get the idea, right? So basically, what we are trying to do is we are taking away from 14, 4 and 8. So the number of elements which are in the intersection of this, right, will be number of elements in the universal set minus number of elements in A minus number of elements in B, right? So in our case, it is going to be 14 minus 4 minus 2. That gives you 8 as the answer, correct? So that is how we are going to figure it out, right? So is that clear? Now let's look into this part. A union B. So when I say A union B complement, then A union B is all these, right? And complement means not these. So when we are talking about numbers in A union B complement, then what we can say here is it is total number is number in the universal set, right? Take away the numbers in A union B, correct? Now A union B, because it's a disjoint function, we get the same formula, right? So this is actually also equal to A union B complement, correct? So we have used that part rather than this, right? So I hope that is absolutely clear. So you could either way do it. The Venn diagram clearly indicates what is the intersection of not A and not B. Perfect. That is how it could be done. Feel free to write your comments and share your views. I hope that makes sense. Thanks a lot for watching and all the best.